Alright, hi 6th grade. We are getting ready to start Module 9, and we are starting with Lesson 1, which is write equations to represent situations. Make sure you are on page 274 in your textbook. You have your connection to vocabulary up in the right-hand corner on page 274. It's one of the vocab words you should have already gotten in your notes. An equation is a mathematical sentence that shows that two expressions are equivalent. So, we can start by thinking of an equation as a balance scale that is level with equal weight on both sides. This little thing right here is a balance scale. The scale shows that you have two quantities that have equal weight. What does the left side of the scale show? Well, to me, the left side of the scale shows that, it says to write our answer in words. We have two triangles. One is equal to 2. The other triangle is equal to 5. And then it says to write a mathematical expression using addition that represents the weight on the left side. So we need to basically just add 2 plus 5 and it equals 7, which is the same number in the weight. Ooh, I'm jumping ahead. So what does the right side of the scale show? Write your answer in words. Well, the right side shows that there's 7 pounds, 7 ounces, 7 whatevers. And then it says to write an integer that represents the weight on the right side. Well, that integer would be 7. Question C is asking, what equation does the scale represent? Well, I'm going to put 2 plus 5 equals 7. So you've got 2 plus 5. That equals 7 because the scale is balanced. So we have the same amount on both sides. If the 2-unit weight was removed, so we're going to get rid of this guy, will the scale remain balanced? What will the scale show if the 2-unit weight were removed? Well, it shows that we have 5 on the left side, and it is not equal to 7 on the right side. Part 2, this is where we get to use a little bit of algebra, kiddos. If a scale is balanced, but a value is unknown, you can solve for the unknown balance. So what equation does this scale represent? We have 4 plus 5 equals 6 plus x. That's my guess. So I'm going to write that here in the blank. I have 4 plus 5, because that's what I have here on the left side, equals 6 plus x. How are we going to solve for x? You need to pause the video and answer this question. How do you think you can solve for x? Write it in your own words. So make sure you've paused the video to explain how you would solve for x. I'm going to go with something like, I know that 4 plus 5 equals 9, so I'm going to try just doing 9 minus 6, the number that's over the value that we know on the right side. And 9 minus 6 equals 3, so x should equal 3. I'm going to try that. 4 plus 5 equals 6 plus 3. Well, I know that 4 plus 5 equals 9. I also know that 6 plus 3 equals 9. For question C, it is asking us if any other values of x would keep the scale balanced, and then explain. So if I put in 2 or 7 or 300 for x, would that keep the scale balanced? Pause the video and explain that. Here's my example for the answer. What other values of x keep the scale balanced explain. I said no, if I used a number greater than 3, the right side would get heavier. If I use a number less than 3, the right side will get lighter than the right. You need to explain that in your own words. On to page 275, up at the top, step it out. It says, Ben buys tickets for the outdoor skating rink as shown. This is where they're showing it. 4 tickets to skate equals $72. Each ticket costs the same amount. How much does 1 ticket cost? So, we first need to start by telling the information that we know. Ben bought blank tickets. Well, it says up here that he bought 4 tickets. And then how much did that cost? It says Ben spent $72. So what do I need to find out? Ooh, I know how many tickets he bought. I know how much he spent total, but do I know how much it costs for one person to go? I have no idea. So what I need to find out is the cost per ticket. You can represent the cost of a ticket with the variable C. Okay? How are the unknown amount C and the amount Ben spent related? So they're related because it all has to do with the cost and the amount of money Ben spent. So I know that the cost of each ticket is some unknown number, but I know that Ben bought 4 tickets. So I could do 4 times C equals $72 because 4 tickets times this unknown ticket price equals $72. Question D says, model the situation using an equation thinking about the different parts. So yes, you still have to be thinking. Write the value or variable for each part of the model. So the first part is the number of tickets bought. It's still what we have up here, 4 tickets. The cost per ticket is still represented by C. For question E, it says substitute values for C to find the solution. Try C equals 20. When C equals 20, the left side of the equation is blank. So if I do 4 times 20, that equals 80. So the left side of the equation is $80, whoops, which is greater than 72. So 20 is or is not a solution of the equation. I'm going to say it is not. And there's your other vocabulary word, 6th grade, a solution of an equation. It is the value that makes the equation true. So basically it's the number that makes the equation correct. Alright, so question F. Try other values for C, thinking about how close your result is to 72. What is the solution for the equation? How much does a ticket cost? Well, I'm going to need to go with something smaller than 20 because 4 times 20 equals 80, which is greater than 72. What about if I try 4 times 19? That would be 38 plus 38. That's $76. So I'm getting closer. Let's try 4 times 18, which would be 36 plus 36. That equals 72. So when C equals 18, 4 times C equals 72. Each ticket costs $18. So let's do check your understanding, and then we will be done with this lesson. So there are 30 students in a class. Today, 26 are present. Write and solve an equation to show how many students are absent. A possible answer could be something like 26 plus A for those absent students equals 30. And then I know that 26, 27, 28, 29, 30. Ooh, so A is going to equal 4. If I substitute 4 in for A, let's try A equals 4. And if I add 26 plus 4, what does that equal? 30 students. Alright, now we're going to do 2, 3, and 4. Determine whether the given value is a solution for the equation. Answer yes or no. So, here we have x minus 8 equals 12, x equals 4. So if I do 4 minus 8 equals 12, if I have 4 and I try to subtract 8, does that get me to 12? No, it does not. That gets me negative 4. So, no. Those are not equivalent expressions. Number 3. 12w equals 36. They're saying that w equals 3. So if I have 12 times 3, whoops, that equals 36. So yes, that given value does make this expression true. If I have y over 8 equals 40 and y equals 5, 5 over 8 equals 40. And no, it does not. So I know that 5 cannot be the correct value for y. Alright, make sure you get all of this in your notes. Make sure you bring this to school tomorrow or submit it on Canvas if you're remote. And then make sure that you've gotten the rest of your notes done too, like your date, the title of the lesson, your learning goal, your vocabulary words, all of that fun stuff. And come to class prepared tomorrow. I'll see you all in class. Bye.